Okay, this is John Reed, Diginomica. I am doing a remote podcast taping for the first time in a long time. Just about all of my podcasts are at events, but this is a real special one. This is an IoT security blowout with Mrinal of Ockam. How you doing?
I'm doing good. Thank you for having me, John.
You guys have had a heck of a year. We're going to get into a little bit of that. You got yourself a bunch of money. You were trying to solve a really vexing problem around IoT security, which you've been engaged in for a long time now. You're the CTO of Occam. We have been trying to cover you guys for a while because we think you're presenting some really provocative and important ideas around this and also contributing heavily to open source. And it seems to me you're trying to solve a couple things. You want to make IoT security a lot easier for developers, but you also want to solve some very vexing problems that are slowing down IoT adoption and creating sensational headlines just about every day. Is that right?
Yeah, yeah, that's true. That's true. Yeah, it's been an exciting year. I'm grateful to a lot of people who've sort of started believing in the approach we're taking to the problem. But yeah, IoT security is a fairly challenging set of issues, and the more people we have thinking about these issues and trying to come up with solutions that developers of IoT solutions can easily rely on and don't have to reinvent the wheel over and over again and get it wrong lots of times. I think the more people working towards that, the better. And so, yeah, it's been quite exciting.
Yeah, and we're going to get into some of the things you guys have been working on this last year and some of the news that you have to share in your latest open source pursuits. The thing I want to share with listeners is that one of the big dangers in my line of work is creating too much content, and I ran into that trap with Mrinal here because we had some terrific email correspondence on a bunch of stuff, including blockchain and IoT security, and I wound up with so much content that I didn't know where to begin. And then I sat on the story for a super long time, which really bothered me. So he's been good enough to join us today for audio because now with a podcast, we know we're going to get something out of this instead of just another piece of content that I have to sort through. So
Well, I enjoyed the emails, John. So
yeah,
it was they were their own reward.
yeah, the emails were great, but I really wanted to surface more, and we'll get into a little bit of what you and I were talking about in the emails around blockchain, but a lot of that I think has evolved since then. The one thing I did want to share with our listeners is that right about a year ago at this time, Jen Howlett, my Diginomica colleague, did a podcast on the Diginomica channel with Mrinal and also I believe with your CEO Matthew Gregory, and those conversations became part of an article that came out last year. So if you do a search for Occam on the Diginomica site, you can find both. And it was episode number 10. In that, they talked a lot about the business of open source because you guys at that time had just announced an open source SDK as basically a foundational technology for securing trust and identity in IoT. So a lot of that conversation was around your approach to open source and the business model around that. So we're not going to repeat what Dan covered last year, but just briefly, kind of how has that been going with open sourcing the SDK since last year?
It's going well. We're still a small team, so we've gone through phases. We've assembled. We did that release beginning of last year. We did a couple of smaller releases through the course of last year. We were able to assemble a little bit of a community, even though it's very small, around that open source project. So we've had few open source contributions. There's some people who've gathered around a Stack channel we have, and we end up having some good conversations about IoT security, cryptography, and the like. And we've, especially in the second half of last year, we've spent a lot of time thinking about which slice of the big, massive IoT security problem we want to focus on first, and what will be our architectural and design approaches to address that. And so that's been what's been going on for the last several months. And what we're starting to do now is open up that conversation in our open source repository as well. So we've created a open source proposals repository. And our idea is, just like a lot of open source languages evolve with open community proposals around the design, and then followed by review of that design in an open environment, We want to take a similar approach because I think security and core protocols benefit a lot from open review and auditing and discussion. And so we want to sort of, we're in the process of bootstrapping that around our open source code right now.
Right. And if listeners want to get immediately involved, just go over to GitHub on Ockam. They have a
GitHub.com/Ockam-network.
And you can basically start contributing to this dialogue there today. The other thing we should just briefly mention, you guys scored a bunch of money, $4.9 million in seed funding as per TechCrunch. That was November 30th, 2019 was their article. So congratulations on that. That should further your cause.
Thank you. Yeah. It's, raising funds is hard, and raising funds from the right investors that believe in your vision is even harder. So I think we got lucky in Core Ventures, Future Ventures, and Okta, who've contributed to the round, and they see the problems we're trying to solve, and they've put their trust in the team to go do something about it. So I'm excited.
Yeah, and you sent me before our talk today, you sent me a slide deck which had 56 slides, which was really fun for me to try to go through 56 slides. Although, fortunately, some of them were pretty quick to go through the way you set it up. But the thing I liked about your deck is you're really honing in on a very specific piece of this problem that you're trying to solve. We're going to get into that. But before we do, I just want to sort of step back a little bit and just acknowledge the scope of the IoT security problem. I mean, I probably put out in my news feed something on this just about every day, if not, every week at least, if not day. I sent you the one recently about hacker leaks password for more than 500,000 servers, routers, and IoT devices. And then I sent you a funny one about security issues with sex toys, which we definitely shouldn't talk about in this podcast. But I mean, this kind of stuff happens all the time. And I guess I just wanted to sort of start with why has IoT security proven such a vexing problem, do you think?
Yeah, I think that's a good question. And you're right. Like literally, if you look back, especially the last maybe 4 years or so since the Mirai botnet incident, it has been news article and breach after breach, right? It's been never ending. And a lot of them exploit very similar problems. So the root cause is, at least in my opinion, that a lot of our traditional approaches to system security don't really apply in the IoT context. So for instance, the traditional approach to securing a system or a network was to put up walls, right? We would have physical walls around our office buildings, and we would have virtual firewalls around our networks. And anything inside the network would be trusted. And this is pretty much how most corporate networks are even today, where everything inside the network would be trusted. Anything coming from the outside would be looked at with a lot of suspicion, and the firewalls will try to filter what gets in, right? However, what we've realized especially over the last decade is that approach doesn't work. We first saw it with mobile devices entering enterprise systems, and then it just the whole thing sort of blew up with IoT devices entering enterprise systems or even our homes, because these parameters around our networks aren't. What we've realized is that they're not good enough to protect us in a world where the devices just can be anywhere, right? They may not be physically in my home or in my corporate office. They could be anywhere in the world, and they're always communicating over the internet. And so we have to change our security model, and that's how we saw, over the last decade, approaches like zero trust being talked about, or Google's Beyond Corp, which is another idea very similar on the lines of zero trust. Essentially, how do we secure devices that are spread all over the internet, and the internet being an untrusted network? How do we still get the same kind of security properties we would like in all our devices that are delivering us data that we rely on, right? And control on remote things that should behave as we expect them to behave.
I'm going to read for our listeners this a very loaded sentence from your slide deck that may take us a little while to unravel, but I think it's really, really important because it pertains to what you're focusing on now and solving an important chunk of this problem. You wrote, decoupling the secure channel protocol from the transport layer protocols removes complexity, minimizes the attack surface, and can enable us to build better end-to-end secure and private systems. And in a note to me, you were a little more informal. You said that decoupling from the transport layer for messaging leads to significant wins. Tell us about sort of not just what that means, but just kind of your journey towards arriving at, okay, this is what we're going to try to solve.
Yeah. Okay. All right. So that took quite a while, right? And as you know, I've been involved in IoT systems now for 7-8 years. And this realization took quite some years to come to.
Right.
However, let me illustrate it with an example, right? So in my house, we have a dog. Her name is Sergeant Pepper. And Sergeant Pepper's alone many a times at home. And if I'm away and it's starting to get dark, I have a connected electrical outlet that I can remotely control from my phone. And it turns on the lights in our living room area. And so she feels comfortable at home, even when we're late. Right?
Nice to look out for Sergeant Pepper.
Oh, well, we love her, right? And we better. So anyway, but here's the challenge, right? So this is a very common scenario. You have a thing you want to control remotely, or you have a thing that you want to receive information from remotely, right? So this flow from devices in my house to my phone, or from my phone, flow of instructions from my phone to devices in my house is a very common flow in IoT, or especially smart home devices. And if you think about how this is really implemented, is sort of like this. The outlet makes a connection with some web service, and my phone makes a connection with the same web service, and then my phone sends a message to the web service then sends a message down to the outlet, right? And we're able to communicate. The reason it is via this web service is because on the internet, because my phone is not a web server, or the outlet is not a web server, or my outlet may be behind my Wi-Fi networks subnet and isn't exposed on the internet. We need this intermediary in the middle, the web service, right? However, this web service in the middle doesn't need to know the contents of my message, right? However, the way these systems are currently implemented, the worst case, the really bad implementations are that the communication between the phone and the web service is completely unprotected and doesn't even use, TLS and HTTPS. And the communication between the outlet and the web service is also completely unprotected and doesn't use any kind of transport layer protection like TLS.
Right.
That's the worst case, and there's no excuse for doing that in 2020. However, a large number of devices, because it's complex to build these systems, still do it that way, and that's just really bad.
Can I just interrupt you for 1 sec? Isn't there an even more kind of worst case aspect to it, which is that once you figure out a vulnerability in one device, the way so many of these are set up by default, you probably have similar access to so many other similar devices as well?
Yeah, that certainly makes certain types of attacks more easy, right? Because you get attackers have figured out that you can use IoT devices as botnets to attack other things. That's what happened with Mirai botnet. Is that because you have one vulnerability in one device and 100,000 of them behave similarly, you can compromise all 100,000, and the effect of that attack then multiplies by orders of magnitude, right? Yes, that's a challenge. But like coming back to our very simple case, the simple scenario of, well, don't protect the communication at all is just unacceptable today. You shouldn't be
Right.
doing it. TLS is easy enough to use. You should be using TLS, especially if your device doesn't have battery constraints or things like that. Which my outlet connected to a power outlet doesn't rely on batteries at all, right? So it should be able to do that correctly. However, that device I currently use doesn't do it correctly from a major smart outlet vendor, right? So, okay, so that's the worst case. The better case is that the implementer of the solution does all the right things. They set up a mutually authenticated TLS connection between my phone and the web service. They set up a mutually authenticated TLS connection between my outlet and the web service. And TLS here is transport layer security, just so I don't keep using acronyms. So, okay, even when they do this, the web service still sees my entire data in the clear and is free to manipulate that data, right? Right. And that's our current best of breed approach. That's the approach that I'm talking about in that sentence you quoted from my slide deck. I think we can do better than that. We already have the tools to do better than that, where the secure channel that we establish doesn't need to be between the phone and the web service and the device and the web service. It can be directly between my phone and the device, just that the path is via the web service, right? So the tools to do that aren't easy to use today, but they exist. The primitives exist. We just have to make it easy for most people to use. And this has far-reaching impacts, and I can keep talking about pause for your thoughts here.
Right, and I think you raised another interesting point there too, which is something that came up in my conversation with Steve Wilson, where we did kind of a Constellation. Steve Wilson, we did a 2-part on identity and also looking at some blockchain issues. But one of the things that came up that I think ties into your example is that I want this to work, but I don't want necessarily the web service to know anything about the fact that I'm not home, that my dog is there. You know what I mean? Like we realize that these devices, in many cases, especially the home use cases, have access to so much privileged information. In the workplace, it might have more to do with things like trade secrets and privileged access areas of the workplace and different things like that. But the same sort of principles apply, which is the device shouldn't have access to that information, right?
Yeah, and back in the 70s, I think, right, experts in computer science back in that time came up with, I think Unix had this philosophy of privilege, principle of least privilege, right? And that's the philosophy we want in our systems. However, the current reality of IoT systems is pretty much everyone has, including people we trust, but also attackers, and everybody has wide open access to most of what's going on in these IoT systems. And so that's the thing to control. And I feel like controlling the communication layer is definitely step one, because all of these things are remote. So if your communication isn't controlled and secured and locked down, you can't really do anything about all the other problems around firmware upgrades and credential management and passwords and all of that. You can only do all of that after you have secure communication addressed. And this kind of answers the question you had earlier around why did we arrive at this particular slice? It's because I feel like you can't really solve all these other problems without first solving the end-to-end secure communication problem.
Right. So what you're hoping to accomplish, like if we fast forward, like let's say a year or two, then if I'm an IoT developer, I now have a good set of out-of-the-box tools that allow me to protect the communication layer when I'm building and configuring apps or device configuration, things like that. Is that kind of what you're thinking?
Yeah, that's exactly right. So our hope is the user experience, the developer experience kind of is like this. if you're building a new IoT device, you just pull the Occam library in whatever language of your choosing, and you build communication using that open source library. And then when you're writing the companion IoT, the companion mobile app, you also pull the Occam library into the app. And then that library just takes care of the secure communication and functions for you. So you don't have to sort of figure all of that out from scratch, regardless of your underlying transport layer connection technology. Could be TCP, DLS, MQTT, or could be low power protocols like LoRaWAN, Bluetooth, etc.
Right, and you're acknowledging that there's that even if you can achieve this, that there's still a number of issues related to transport layer and such, but you want to start with some of the issues around communication that are really concerning as a starting point.
Yeah, that's exactly right. So the idea is there are other issues that could be solved on top of this. So for instance, one of the things IoT systems have to do is firmware upgrades, right? And you could imagine that someone could build a firmware upgrade solution used on top of Occam's open source secure communication libraries, right? But we're not, similarly, you could talk about how credentials are exchanged and how authorization and access control is done. We're doing some of that, but a lot of that will be very specific to enterprise use cases. And we imagine that other people will build things on top, and so forth, right? There's a whole suite of IoT security problems that can then be solved on top of the secure communication infrastructure.
Right. And in your slide deck, it helpfully says that you guys are building a multi-language open source library that makes it easy to add secure messaging to IoT systems. I think that's a good summary. How would you sort of specifically to just describe in this type of example you gave me, what does secure messaging look like? Like how does that play out?
Right. So the term secure messaging really came from like human to human communication scenarios. So for instance, if you use any of the modern messaging apps on your phone, like WhatsApp or Signal, they do end-to-end encrypted communication. And we're trying to bring that same idea and same set of approaches to IoT systems. But I want to sort of emphasize that when people hear encrypted, they almost automatically think that the goal is confidentiality. However, encryption or cryptography gives us more than confidentiality. It gives us other attributes that are often more important to IoT systems. So for instance, if something remote is sending you a message, it's very hard to know that message actually came from the thing you think it came from, right?
Right.
So in my scenario, when it comes from the outlet, or if I send an instruction to the outlet, what's the proof that no one in the middle actually manipulated that message to either change the sender of the message or flipped a bit and turned the value 100 into 36 or something, right? How do you validate that? And cryptography is our tool to validate identification, authentication, and data integrity. So you mitigate against manipulation and tampering of data and forging of the identity of who sent you that data. So that's equally important to confidentiality. Confidentiality is also something you get out of encryption, but these other attributes are important. So a lot of times people will say, hey, my system doesn't need cryptography or encryption because I don't, my use case is such that confidentiality is not important. But what they're forgetting is that pretty much if your data is going to be useful and valuable to some use case, you definitely want to know where the data came from, right? You still care about the integrity of the data. Otherwise, it could just be garbage and there's no value in it. So if your data is valuable and your use case is valuable to somebody, that somebody cares about whether or not they can trust the origin of that data. And so data integrity and protection against forging of identities is what you can get out of cryptography and secure communication. So to answer your question, we're trying to bring end-to-end encrypted exchange of messages to IoT systems. In a home scenario, that means generally communication between devices in my home and my phone, or my wife's phone, or phones in our family. But in an enterprise scenario, it means that when data is, so for instance, let's imagine like a hospital. In a hospital, there are hundreds of vendors that deploy connected devices. And currently, the way IoT systems are set up is that all those devices phone home to the vendor's website. And then the vendor's website sends the data over to some central system integrator's IoT platform. And then the system integrator sends the data over to the hospital's enterprise system. And that enterprise system then sends it over to some maintenance staff's phone or some doctor's phone, right? And in that flow, a very large surface of systems and devices get to see and potentially manipulate the data on its path. And sometimes this path can be, 20 steps long, right? Or 30 steps long. And these steps aren't, jumping in internet routers. It's steps between systems in real world IoT systems. So since our principle is principle of least privilege, we want to close all of this down and then open it selectively rather than have everything be open. And then you're continuously playing this sort of whack-a-mole game, right? Of we got a security bug here and we got a security bug there and we got another security bug. And that's a never-ending game. It's much better to close it all down and then be deliberate about who gets to see data. Should they have the privilege to see this data? What portion of the data do they really need to see? So for instance, in case of a connected machine in a hospital, the manufacturer only needs to see operational data about the machine. They don't need to see application data about the patient, right? And if you use cryptography and end-to-end encrypted messaging, you can build that control into the system and into the data flows of the system.
I'm really glad you brought that example up, this whole least privilege thing, because I'm waiting to see some headlines around hacks and security breaches where it says things like, yeah, there was a major breach of information, but only 15 accounts were accessed, or alternately, 1 million accounts were accessed, but they only got access to the ID or nothing else.
Hey, John, your sound
these hacks.
Your sound got garbled in the last sentence. Could you say that again?
Okay. Yeah. Well. So my issue is basically, we see these headlines all the time, and I'm glad you talked about the containment issue, because all these headlines are always like, 500,000 devices got hacked and all this compromising information came out. Like, when are we going to start seeing headlines that say things like, there was a compromising breach, but it only affected, 10 accounts, not, 1 million, or alternately,
right.
or alternately 1 million account, 1 million devices were compromised, but all they got was the ID number and nothing else. Do you know what I mean? Like we don't see enough of these stories of containment. It's always like these breaches are always brutal,
Yeah, because the reality of IoT, if you look under the hood at most IoT systems, the reality is things are, either completely wide open or they're protected by a thin boundary. And the moment someone breaches one boundary, it's suddenly a free for all inside, right? And they can pretty much see everything. So that needs to be changed. And so you're in the beginning of this call, you asked why is it so hard? The reason it's hard is because the attack surface is just so massive and the complexity becomes so massive that it's very difficult to think about putting in these controls. And you oftentimes, if you're in the middle of these situations, you oftentimes don't have control over the system architecture. So even if your own little piece works, somebody else's piece doesn't work. And I'll give a for example there. I've seen over the last maybe 3 years, we've seen the emergence of a lot of vertically integrated IoT platform stacks, right? So it started out with a IoT platform only had a server side component. And then later on, a lot of vendors, including my previous company, realized that we needed components in the edge and in the cloud to be able to vertically control the security of these systems. And we then similarly saw Amazon came out with Greengrass, Azure came out with Azure Sphere. And a lot of these are efforts to having a full end-to-end vertically integrated platform because it gives you control over the path of the data, right? However, the reality of systems is that everyone is either trying to build this vertical stack and everyone's stacks don't talk to each other, or they talk to each other in insecure ways, or people just ignore the vertical integration. They try to do things ad hoc and piecemeal things, and it becomes very complex, right? So the equilibrium state eventually in the future is that there will be horizontal tools to solve specific problems. And we kind of saw this, my co-founder Matt likes to say, we kind of already saw this in the cloud world where, 10 years ago or 15 years ago, everybody was trying to build vertical platform as a service solutions. And now everybody's building these horizontal tools, right? And the world's transition into it. And I think very similar thing will happen in IoT, where right now you have these tightly integrated vertical platforms, but the security answers in that scenario cannot be scaled because, what about scenarios where data transfers between these platforms and so forth? So I think these horizontal tools is where the future will be, and how we will get a handle on this containment picture. And at Ockam, we're trying to be the very thin horizontal tool that gives you secure communication.
Right. And, there may be some listeners who are feeling like, well, this was a little technically dense for me today. And my response to that is basically tough luck. I think you need to understand this stuff. I mean, the thing is that data literacy underscores everything right now. And we need to understand data literacy. I mean, just to give one example, you used the WhatsApp and encryption example, the WhatsApp example a while ago. That's also an area where our federal government authorities have expressed concerns around the lack, for example, of backdoors into that type of encryption. Mm-hmm. And there's ongoing controversy around that, to the point that Apple recently disclosed, or it was reported, I don't know if they disclosed it, I think someone found out, but that their encrypted solutions in the cloud were not as end-to-end as their devices, basically based on pressure from government agencies. So the point being, like this is not just a technical solution. This is a cultural and political problem as well. And I think it's really, really important that we try to grapple with it. So that was one of the big reasons why I wanted to have you on this call, is because I think we have to understand the technology as well as the policy if we're going to make smart policy around this.
Yeah, no, I agree completely, and I'm glad to be on the call. The backdoors into encryption debate is super interesting and very political. So I think it's a understanding what is at stake is important, right? I don't think anyone is arguing for let's keep everything open for all attackers and all hackers to come in, right? The argument is really around let's have security, but then give law enforcement control and visibility into select scenarios, right? And that in the WhatsApp world is a reasonable discussion to have, because in the WhatsApp world, you now have end-to-end security, and you can talk about, well, what should law enforcement be able to see, or should they be able to see or not? But in the IoT world, well, we don't have any security or, a thin veil of it. So we first need to actually catch up and get to a point
Yeah.
where we do have control. And then, yes, these debates will become important at that stage.
Right, and in that sense, I'm not necessarily advocating a certain position on all of that. I'm advocating that we need to kind of really understand all the different nuances of how all this stuff works, so that we can figure out like how to embrace the type of security we need, but also, like you said, in some cases there may be a need for certain kinds of access. I think those are very difficult problems, but there are problems that we need to solve with better information than most of us have right now. So I did want to go through a couple of scenarios in your slides real quickly, because you called attention to a few industry examples, and if you could just quickly walk us through those. One had to do with new protocols. You used Apple's Find My as an example. Why does that stand out to you?
Right. Okay. So let's say you're a small IoT company. Apple has this. Actually, I'll back up a little bit. Apple has this functionality where if you lose your phone or your AirPods or some other Apple device, that device starts broadcasting a cryptographic public key over Bluetooth. And nearby devices of strangers can take that public key and encrypt information for that public key and upload it to the cloud. And because that public key is a derivative of a different public key or a different key pair, if you're the owner of that device, you're able to decrypt that information and discover where in some park you left your AirPods, right?
Right.
And that's a great example of a cryptographic protocol being really, really useful. It doesn't reveal my devices to strangers, and it allows me to find my devices, right? It's pretty cool. And it doesn't reveal the location of my devices to even Apple, right? And that's a great protocol. But if you're a builder of a new IoT device and you want to build this, that's a very daunting task, because you then have to go figure out all sorts of communication protocols, all sorts of cryptography protocols. Even if you put in the effort, the odds that you would get the cryptography wrong, because it's a very complex, advanced field that people spend 30, 40 years learning and researching, those odds are very high, right? So if you wanted to build such a protocol and there existed a secure messaging infrastructure that did 85% of the work for you, then it becomes a much easier hurdle to think about these further privacy preserving but useful scenarios, right? And protocols. So that's why I was highlighting that one.
Yeah, exactly. You can't really have the massive development team that Apple has, but with a shared standard, you do get a leg up, which is a big deal. And then in your next one, you talk about federated learning. Google Keyboard used as an example, where you can teach it out of vocabulary words without exposing sensitive text to any servers, and that connected sensors could learn in similar ways on a device-specific way. I like that.
Yeah. So the reasons things get connected to the internet, especially IoT type things, right? Typically fall in the bucket of reason number one is I need to access it remotely. And we already talked about why in that scenario, the web service can just be a router. The web service doesn't need to see the content of the message, right? So that's scenario number one. The second scenario or second reason why people connect things to the internet is that individual sensors can become better at sensing something if they can collaborate with other sensors of the same type. So, you might remember the Nest Learning thermostat commercials, right, from a few years ago. Essentially, what Nest was able to do is they are better at recognizing how you would whether or not you're in the house, or what is the appropriate temperature you like, or how much energy your heating system is consuming. Those factors the Nest thermostat is better at learning compared to my old traditional unconnected thermostat, right? But to do that, the Nest thermostat has to send private data that is private to me up to some cloud from 100,000 users, and then they can apply machine learning to those 100,000 users' data, and they're able to arrive at better thresholds that can then be sent back to each of the Nest thermostats, and they can make better decisions, right? And so this learning use case is a valid use case for IoT to improve the accuracy and intelligence of connected devices. However, it has this flaw of revealing lots of data. And so Google, over the last, especially the TensorFlow team, TensorFlow is a machine learning tool from open source machine learning tool from Google. And the TensorFlow team has been talking a lot about this idea of federated learning over the last few days and the last few years. And they've also released some open source code around it. But the idea is that the Google keyboard in Android devices needs to learn words that no one else in the world has ever typed. And they learn it by me typing that word into a keyboard. However, if you take the traditional approach of machine learning, that word that I just typed would have to be sent to the internet, and some machine learning model would be applied that would count how many times this word is used by lots of people. And if it's used enough number of times, they will include it in their vocabulary, right? However, this means revealing what I'm typing on my phone up to a cloud. In the federated learning model, what Google has been able to show is that they can still learn these words without revealing who typed which words. And they do that by federating the learning model down to each individual device, where some of the learning actually happens in the device. And the reason I quoted this example is that I think that a lot of IoT devices can benefit from this shared learning. For instance, in my previous job, we were doing sensors on city streets, and city streets are a very dynamic environment, and accurately sensing movement of cars and things like that on city streets can be very hard for an individual sensor, but a lot easier for a machine learning model that's consumed data from lots of sensors, right? So in these accuracy improvement scenarios, there are mechanisms that are starting to emerge that, like federated learning, that allow us to do improvement of accuracy without compromising privacy and security. But to build such a system, well, step one, you need secure communication. And so once you have secure communication, you can then have a federated learning model on top.
Right. I'm not going to get into the third one because we're running low on time, but I'll just read it for the listeners. You have another scenario around zero knowledge proofs and how Mozilla is using non-interactive zero knowledge proofs to collect telemetry from the Firefox browser without collecting any private browser usage. And you're saying that a large subset of IoT use cases is telemetry collection. I'll leave that to users to explore that one. But the point being that you've been able to cite several industry examples that tie back into things that you think you can apply to these enterprise IoT developer cases. So that's good stuff for us to kind of look at. The final thing I really wanted to talk with you about is just the blockchain piece of all of this, because one thing I was really happy about is that you didn't really get into blockchain stuff at all in your presentation and in your discussion today, and for a few different reasons. One is that I think there's just so much hype around it, and so many peaks and valleys of inflated and deflated expectations. It's alive, it's dead, it's wonderful, it's deeply flawed, it's immature, it's got performance issues, whatever the narrative may be. My view is that we're trying to solve real world problems. Exactly what technologies we use to solve them is not always the most important thing here. And so I was glad that you kind of avoided putting that at the center of everything. But having said that, I do want to ask you, kind of how your views on blockchain have evolved and sort of the role of blockchain in the solutions you're envisioning going forward.
Right. So my approach to technology is it's a set of tools, right? And we should
Yep.
view them as tools. And a lot of times the hype takes over the reasoned approach to considering whether this tool is the best tool for this job, right? And so we've seen a lot of that where people have proposed blockchain will solve all the problems in the world, and I think that's just that's talk all smart people can ignore. But blockchain, not necessarily the data structure, but like the all-encompassing sort of technology as a whole, does have some valid, useful new things, new features as far as a tool is concerned. One of the key new features it has is that we can use it to think about systems where you want to assume that some of the parties may become malicious at some point in the future. So if you want a database where not everybody should be trusted forever, you can create this shared database, and blockchain is a good tool for it. More specifically, a Byzantine fault-tolerant consensus system is a good tool for it, right? And that's not a new technology. Leslie Lamport and folks back in like the 80s talked about BFT, and there are designs that have followed that legacy even till now. But blockchains made all of that a lot more accessible, and that community is doing a lot of very cool work around that field. So it's a tool to create a database where I don't want to necessarily trust all the participants forever. And it's a shared database. And IoT systems are inherently multi-party, right? So taking that enterprise example we took earlier, like a hospital, in a typical hospitals, let's say you consider that there are, 20,000 connected devices installed in a hospital. It's fair to assume that there are 20 or 30 or 40 different device vendors involved in those 20,000 devices. And there's the system integrators that the hospital hires, or there are system integrators that the overall managing company of a chain of hospitals hires, et cetera, right? So you end up with a system where hundreds of parties are involved in deploying and maintaining that system. And there are certain scenarios where, for example, identity of devices in that shared database, where you can benefit from having a shared database that anyone can write to, but no one party can manipulate without letting everyone else know that they tried to do malicious things. In those scenarios, a Byzantine fault-tolerant database, or AKA a blockchain, can be a very useful tool. And in fact, we see, even though the hype of blockchain only happened over the last few years, we've seen large deployments of such an idea already. So I'll give one example. In the web public key infrastructure space, Google started deploying back in 2012 or something, this protocol called a certificate transparency, which tries to protect our web browsers from malicious certificate authorities. And certificate authorities are essentially authorities that validate web addresses, right? And web addresses are just identities. So an authority can say, if your browser trusts my authority certificate, I can vouch for the fact that this website you're looking at is xyz.com, right? However, over the period of 20 years, some of these certificate authorities will go rogue or get compromised, etc., right? And there are hundreds of them all around the world. So what do you do when that kind of thing happens? If that happens, you could technically end up in a scenario where you wouldn't be able to trust any website in your browser, right? So certificate of transparency, which has ideas that are very similar to the more recent blockchain ideas around having immutable logs that are signed, that are audited by lots of parties, etc. The very similar ideas is currently in deployment, and oftentimes when you see that big red screen on your on your web browser that says don't trust this website, it's because of that certificate transparency log, right? So similarly, coming back to IoT devices also need an identity layer and a proof of that identity. And blockchain is an interesting tool to use for that purpose because we inherently are, IoT systems are inherently multi-party systems, like my hospital example. And IoT systems are more complex than the web PKI infrastructure or the web public key infrastructure because IoT systems are changing a lot faster. There are more devices involved. The devices are remote, and they not only need identity proofs, but they also need proofs of credentials and which device is authorized to do what, and which other device is authorized to do this other thing. And that authorization layer is all about issuing credentials and revoking credentials. And certificate revocation, even in the web PKI infrastructure, which is now 20 years old, is still an unsolved problem. And Google and others, Mozilla, etc., are trying to solve certificate revocation for the web. IoT systems need to solve certificate or credential revocation for IoT devices. And in that scenario as well, blockchain is an interesting tool. So my advice to the listeners and in general to anybody I speak with is ignore the hype and look at the unique properties this new tool gives you and think about how it may be applicable to your particular situation. Right.
That makes sense. Would it be fair to say then, in terms of your current approach to blockchain, that it doesn't appear to me to be core to the open source tooling that you're developing at the moment, but that it could become very important, perhaps in certain industry use cases that get developed using that? Is that kind of a good way of looking at it?
Yes, sort of, right? And so what we've done over the last year is that since we were narrowing down our focus, right, we knew going in that device identity is a complex problem. We knew going in that credentials are a complex problem. But what we realized over the last few, 6 months or so, is that we need to solve secure communication before going after identity and credentials in a full-fledged way. So what we're doing right now is we're building that secure communication layer, and our sort of second step is secure identity and secure credential management, and it sits on top of the secure communication layer. And for secure identity and secure credentials, blockchain will have a role to play. But even before we need to think about these shared databases around for credential revocation or identity registry, we can get very far with just simple cryptographic primitives. So we're trying to keep things simple until we really have to get into this, get into relying on blockchain technology, especially because there's a lot of very interesting research work that's currently going on within the blockchain community. So for instance, there's a lot of very nice papers that have come out over the last maybe year or so from VMware research, and that has shown how we can scale 30-year-old practical Byzantine fault tolerance solutions in new ways. They have a paper called Hot Stuff that tries to do that. So there's a lot of interesting research going on, and our current approach is we'll take on whatever is the latest useful tool available when we get to it. Currently, we feel like there's enough for us to solve even before we have to think about blockchains and their use cases.
Yeah, I like how you frame that, because in some ways you sort of dismantle the whole thing by pointing out that some of these similar technologies have been in use for a very long time. And then there's another thing around the new iterations of blockchain needing kind of more maturity and development. And this all makes sense to me. I mean, some of my readers who are more blockchain, kind of, I don't know what the right word, advocates than me, they give me pushback on this. I'd simply tell them that tools are valuable, but use cases are paramount, and let's focus on the use cases of today. And then perhaps a year from now, when you guys are further along, we can have a more interesting blockchain conversation talking about what's actually being applied in this case, because to me, that's where it gets interesting, is when you actually can talk about applying it and how customers are using it. And I do think eventually there probably will be some things to talk about there, but right now I'm happy to postpone that. I think you've summarized it well.
Cool. Yeah, I think so too. I think there is useful technology there. It's just eclipsed by all the hype somewhere in that smog, right?
Yeah, and unfortunately, so much of the positioning around it editorial is either like it's it's dead or it's going to be big this or this is the year of it. Like there's so little of that kind of more sober analysis of like, hey, here's exactly what it's good for. Here's exactly what it's not good for. Here's exactly where we are with performance and scale issues. Blah blah blah. But anyhow, we can revisit that another time. I think we've elapsed our allotted time for today. But thanks for that excellent discussion, and just want to remind listeners that that Ockam is relying on open source for this. We'll put a link into the podcast description, and if you want to give one more pitch for getting involved, that's probably a good way to wrap up.
Yeah, we can use all kinds of help. If you have an IoT use case that has security challenges, come talk to us. Talk to us about the use cases. Come talk to us about different real world challenges you've experienced or are experiencing in your organization. And you can contribute those user stories as pull requests into our open source repo, or you can contribute to documentation, discussions, and of course source code. So it's all out in the open, and we're trying to be really, really open and engaging to hopefully build the community's confidence in our approach. So please stop by and say hello and tell us about your IoT use cases.
Cool. Well, I'm really glad you're bearing down this problem. I don't want to read any more stories about people terrorizing other people's babies and kids with Amazon Ring devices and stuff like that. So I'm glad you're bearing down, and I'm really looking forward to seeing the progress that gets made on this over the next year or two. So we'll revisit this in the future. Thanks for taking the time.
Well, awesome. Thank you so much for having me, and thank you everyone for listening.
Cool.